Hello, hi everyone. Welcome to the Student the Brand. So this is our Shiva sir. Today we are going to discuss about light reflection and refraction chapter. Light reflection and refraction. Light is a form of energy which gives the sensation of sight. Light is a form of energy which gives the sensation of sight is called. Light is a form of energy which gives the sensation of sight is called. Light is a form of energy which gives the sensation of sight. So light reflection and refraction, light reflection and refraction. Light reflection and refraction. CBSE Grade 10 Physics. CBSE Grade 10. CBSE Grade 10 Physics. CBSE Grade 10 Physics. Light is a form of energy which gives the sensation of sight. Light is a form of energy which gives the sensation of sight. CBSE Grade 10 Physics. CBSE Grade 10 Physics. Physics. CBSE Grade 10 Physics. CBSE Grade 10 Physics. CBSE Grade 10 Physics. Light is a form of energy which gives the sensation of sight. Light is a form of energy which gives the sensation of sight. New Cartesian. New Cartesian. New Cartesian. New Cartesian. New Cartesian. Sign convention. New Cartesian. Sign convention. All distance measured from the pole. Distance positive along the instant trace. Distance negative opposite to instant trace. Distance positive above the principal axis. Distance negative below the principal axis. New Cartesian. New Cartesian. Sign convention. New Cartesian. Sign convention. New Cartesian. Sign convention. All distance measured from distance positive along the instant trace. Distance negative below the principal axis. Distance positive along the instant. Distance negative below the principal axis. Distance positive along the instant. Distance negative opposite to instant. Distance positive above the principal axis. Above the principal axis. Distance negative below the principal axis. New Cartesian. Sign convention. New Cartesian. Sign convention. All distance measure from the pole. Distance positive along the instant. Distance negative opposite to instant. Positive along the instant. Distance negative opposite to instant. incident ray distance are positive, above the principal axis distance are negative, below the principal axis. Myopia, 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 myopia. Near distance we can see, far distance we can't see. Myopia, myopia, myopia. Near distance we can see, far distance we can't see. For that correction we are using concave lens, concave lens, concave lens, concave lens. Hypermetropia, 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 hypermetropia. Far distance we can see, near distance we can see. Far distance we can see, near distance we can see. Far distance we can see, near distance we can see. Far distance we can see, near distance we can see. Hypermetropia, hypermetropia. For that correction, we are using convex lens, convex lens, convex lens, convex lens, convex lens. In the history of physics, light reflection and refraction, in that a lens is the most demanding topic, that is convex lens and concave lens. Convex lens and concave lens. I'll show you the convex lens. Convex lens. This is the convex lens. This is the convex lens, right? Convex lens. You want to see the concave lens? You want to see the concave lens? So this is the convex lens. Convex lens. Concave 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 lens. Yes or no? Concave lens. Concave lens. Now we will discuss about reflection phenomena. Reflection phenomena. Reflection phenomena. Reflection phenomena. Bouncing back of the light from the reflecting surface. Bouncing back of the light from the reflecting surface is called reflection of light. Incident ray, reflected ray, normal line, normal line. The line is perpendicular to the plane mirror. The line which is perpendicular to the plane mirror is called normal line, normal line, normal line. Normal. I am considering your incident ray. The light which is incidenting on the surface, that is called incident ray. Incident ray. The light which is reflecting back is called reflected ray. Reflected ray. Reflected ray. Come on. The light ray which is deviating, undeviating line, undeviating line. The angle between incident ray, normal line is called angle between incident ray and normal line is called angle of incident. Angle between reflected normal line is called angle of reflection. Angle between reflected and deviated, undeviated line is called angle of deviation. angle of deviation, angle of deviation, angle of deviation. What is angle of incident? Angle between incident and normal line is called angle of incident. Angle between reflected and normal line is called angle of reflection. Angle between reflected and undeviated line is called angle of deviation. From the laws of reflection, angle of incident ray. Incident ray, reflected ray, normal line, incident ray, reflected ray, normal line, incident ray, reflected ray, normal line, lies in the same plane. Incident ray, reflected ray, normal line lies in the same plane. Angle of incident is equal to angle of reflection. Incident ray, reflected ray, incident ray, reflected ray, normal line lies in the same plane. Angle of incident is equal to angle of reflection. These are laws of reflection. Laws of reflection. Laws of reflection. Incident ray, reflected ray, normal line, lies in the same plane, lies in the same plane, lies in the same plane, lies in the same plane. Angle of incident is equal to angle of reflection. Angle of incident is equal to angle of incident is equal to angle of reflection. These two are laws of reflection. These two are laws of reflection. These two are laws of reflection. Now I am considering here the angle is linear angle is 180 degrees. 180 degrees. Angle of incident. Angle of incident in the linear angle. On the linear angle you can see angle of incidence plus angle of reflection plus angle of deviation equal to 180 degrees. 180 degrees. Everybody listening? 180 degrees. Angle of incidence plus angle of reflection plus angle of deviation equal to 180 degrees. Angle of incidence. Angle of incidence plus angle of reflection plus angle of deviation equal to 180 degrees. From laws of reflection, from laws of reflection, from laws of reflection, from laws of reflection. Angle of incident is equal to angle of reflection. Angle of incident is equal to angle of reflection. Angle of reflection. Angle of incidence, angle of incidence, angle of reflection equal to 180 degrees. Angle of deviation equal to 180 minus 2 angle of incidence. Angle of deviation equal to 180 minus 2 angle of incidence. In the place of angle of reflection, I am substituting angle of reflection plus angle of reflection plus angle of deviation equal to 180 degrees. Angle of deviation equal to 180 minus 2 angle of reflection. Angle of reflection. Angle of deviation equal to 180 minus 2 angle of reflection. Angle of deviation equal to 180 minus 2 angle of incident. From laws of reflection, angle of incident is equal to angle of reflection. Angle of deviation equal to 180 minus 2 angle of reflection. Angle of deviation equal to 180 minus 2 angle of incidence. This is about the bouncing back of the light from the reflecting surface is called reflection of light. The bouncing back of the light. The bouncing back of the light from the reflecting surface. Reflection of light. Reflection of light. The bouncing back of the light from the reflecting surface is called. The bouncing back of the light from the reflecting surface is called reflection of light. The bouncing back of the light from the reflecting surface is called reflection of light. Laws of reflection. Laws of reflection. Incident ray, reflected ray, normal line. Reflected ray normally lies in the same plane. Angle of incident is equal to angle of reflection. Angle of incident is equal to angle of reflection. Linear angle is 180 degrees. Angle of incident plus angle of reflection plus angle of deviation equal to 180 degrees. 180 degrees. So from laws of reflection. Angle of incidence plus angle of incidence plus angle of deviation equal to 180 degrees. Angle of deviation equal to 180 minus 2 angle of incidence. Angle of deviation equal to 180 minus 2 angle of reflection. 2 angle of reflection. Laws of reflection and reflection phenomena and angle of deviation. Angle of deviation. Angle of incident is nothing but angle between reflected ray, incident and normal line is called angle of incident. Angle between reflected and normal line is called angle of reflection. Angle between incident and normal line is called angle of incidence. Angle between reflected ray normal line is called angle of reflection. Angle of reflection. What are the laws of reflection? Incident ray, reflected ray, normal line lies in the same plane. Lies in the same plane. Angle of incident is equal to angle of reflection. Angle of incident is equal to angle of reflection. These two are laws of reflection. Laws of reflection. Now we are going to discuss about regular reflection and irregular reflection. That is about types of reflection. 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 Regular reflection. Irregular reflection. Irregular reflection. Regular reflection. What are those? What are those? What are those types of reflection? Types of reflection: regular reflection, irregular reflection, regular reflection, irregular reflection. What is regular reflection? What is regular reflection? Regular reflection is nothing but when the incident light rays are parallel to each other. When the incident light rays are parallel to each other, reflected light rays also parallel to each other. I am telling all of you, what is regular reflection? Regular reflection is nothing but incident light rays are parallel. Then reflected light rays also parallel to each other. This type of reflection is called regular reflection. If the incident light rays are parallel, then reflected light rays also parallel to each other. Regular reflection. Incident ray. Incident ray. Incident ray. Incident ray. I am taking this. Light rays are parallel to each other. Yes or no? These light rays are parallel to each other or not? Yes or no? Yes. Reflected light rays are also parallel to each other. Reflected light rays are also parallel to each other. This type of reflection is called regular reflection. Incident beam, reflected beam, reflected beam. So I'm considering regular reflection takes place on smooth surface. Regular reflection takes place on smooth surface. Regular reflection takes place on still water. Regular reflection takes place on smooth surface. That is called plane mirror. A regular reflection also takes place on still water. Still water. Now I am saying the irregular reflection. Irregular reflection. Irregular reflection, irregular reflection. I am taking the rough surface. This is the rough surface. Rough surface. Rough surface. Incident beam is parallel. Incident beam is parallel. But reflector light rays are not parallel to each other. This type of reflection is called irregular reflection. Irregular reflection. If the incident light rays are parallel, then reflected light rays are not parallel to each other. That type of reflection is called irregular reflection. Incident beam is parallel, but reflected light rays are not parallel to each other. This type of reflection is called irregular reflection. Irregular reflection. Irregular reflection. This type of reflection is called irregular reflection. Irregular reflection takes place on rough surface, rough surface, rough surface, rough surface. Regular reflection takes place on smooth surface. Irregular reflection takes place on rough surface. This is rough surface. This is smooth surface. Regular, 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 irregular. Yes or no? So I'm taking this is a regular reflection, irregular reflection, irregular reflection, regular reflection, rough surface, smooth surface, regular reflection, rough, irregular reflection, smooth, regular, reflection, regular reflection takes place on smooth surface. Example, plane mirror, still water, rough surface, 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 irregular reflection, rough surface, irregular reflection takes place on plane mirror. So like we can say paper, wall. There is one question, 3 marks question, very important question. So there is one question. So reflection takes place on wall and reflection takes place on smooth surface. What is the difference between these two reflection? On rough surface, on wall, irregular reflection takes place. On plane mirror, regular reflection. Regular reflection. On plane mirror, on plane mirror, on plane mirror. I am saying to you, the plane mirror, regular reflection, on, 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 wall, irregular reflection, yes, irregular reflection. Next, we'll go to the object and image. So come on, we'll go to the object and image. Object and image. Object and image. So object and image. I'm taking this one. So I'm considering the plane mirror. Plane mirror, this is the object. Light rays are coming from here. I'm considering here also. These are the reflector light rays. These are the reflector light rays. Reflector light ray, reflector light ray. If you are extending those reflector light rays will meet at one point. Those reflector light rays will meet at one point. Their image is forming. That is virtual image, virtual image, virtual image, virtual image. Extending in reflector light rays. Extended reflector light rays are meeting at one point. Their image is forming. That image is called virtual image. Virtual image, virtual image, virtual image. These are the light rays are coming from infinity. After reflection, light rays are meeting at one point on the principal axis, 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 principal axis. On the principal axis, reflector light rays will meet. The image is called real image. That image is called real image. The point of intersection of reflector light ray. Point of intersection of reflector light rays. Point of intersection of reflector light rays. That is called real image. That is called real image. The point of intersection of reflector light rays is called real image. So I'm considering here this is the virtual object. We are extending these incident light rays. Incident light rays are extending there. Object. That object is virtual object. So we are extending the incident light rays. Those incident light rays are meeting at one point. Their image is forming. That is called virtual object. Virtual object. And here you can consider reflector light rays are meeting at one point. Reflector light rays are meeting at one point. Their image is forming. That is virtual image. So here from this point light rays are coming like this. Yes or no? From this point light rays are coming. This point is called real object. From this point light rays are coming. That is real object. After reflection light rays are moving away from the principal axis. If you are extending, reflector light rays are meeting at one point. That is called virtual image. Extending reflector light rays are meeting at one point. Their image is forming. That is a virtual image. Here we are incident light rays are falling after reflection. Directly light rays, reflector light rays meet directly. That is called real image. Come on, real image. That is called real image. Yes or no? Real image. What is the real image? The point of intersection of reflector light rays. That is called That is called real image. We're extending the incident light rays, extending the incident light rays, extending the incident light rays. Their image is their virtual object. Extending incident light rays, extending incident light rays. There, that is a virtual object. That is a virtual object. Yes or no? Yes or no? Here you can see from the real object, light rays are coming after reflection. Those are moving away from the principal axis. If you are extending those reflector light rays, so image is forming, that's a virtual image. So incident light rays after reflection, the light rays will meet at one point, their image is forming, that is a real image. So if you are extending the incident light rays, that is a virtual object. Virtual object. So we can conclude that object is real, image is virtual, object is virtual, image is real. Yes or no? So this is very very important. So remember this point. Next one. So we'll go to the next topic. That is so plane mirror, object, light rays are coming from the object. So actually when the light ray is passing along the normal line, if the light ray passes along the normal line, what happens? It reflects in the same direction. If the light ray passes along the normal line, if the light ray passes along the normal line, if the light ray passes along the normal line, it reflects in the same path. So it moves in the same direction after reflection. So here also, if the light ray passing along the normal line, so incident ray, reflected ray. So I'm considering one more light ray. So it will be reflected. So I'm considering one more light ray here. So incident ray, reflected ray, incident ray, reflected ray. So small break. So now you can see here we are extending the reflector light rays. As I said, reflector light rays will meet, their image will form. If the reflector light rays are meeting, their image will form. So I'm considering here. If object is real, image is virtual. If object is real, image is virtual. Object is virtual, image is real. Second one, object distance. The distance between object to mirror. This one is the mirror. Object, image. So the distance between object to mirror is called object distance. The distance between object to mirror is called object distance. The distance between mirror to image is called image distance. The distance between object to mirror is called object distance. The distance between mirror to image is called image distance. So in the plane mirror, object distance is equal to image distance. In the plane mirror, object distance is equal to image distance. Third one, height of the object is equal to height of the image. Height of the object is equal to height of the image. Height of the object is equal to height of the image. Height of the object is equal to height of the image. Fourth one, it also shows lateral inversion. What is lateral inversion? The phenomena of converting of right side of the object appears to be left side of the image. Left side of the object appears to be right side of the image. This mirror image is called lateral inversion. Okay. So what is the object distance is equal? So object is real. Object is real. Object is real, image is virtual. Object is virtual, image is real. Object distance between object to mirror. Object to mirror is called object distance. Distance between mirror to image is called image distance. Object distance is equal to image distance. Height of the object is equal to height of the object is equal to height of the image. Height of the object is equal to height of the image. It also shows lateral inversion. What is the lateral inversion? The phenomena of converting of right side of the object appears to be left side of the image. Left side of the object appears to be right. Left side of the object appears to be right side of the image. Right side of the object appears to be left side of the image. The phenomena of converting of right side of the object appears to be left side of the image. Left side of the object appears to be right side of the image. This mirror image is called lateral inversion. This mirror image is called lateral inversion, lateral inversion, lateral inversion, lateral inversion, lateral inversion. So that's enough. Next, the spherical mirror. Spherical mirror. The mirror which is in the form of spherical mirrors, there are two are there, spherical mirrors. So I am taking like this. So I'll draw the circle. So I'm considering here a small portion is called mirror. I'm taking the small portion that is called a mirror, right? The small portion is called mirror. So now I'm considering here. So there are two types of mirrors, concave mirror and convex mirror. Concave mirror and convex mirror. Concave mirror and a convex mirror. Okay. Concave mirror and convex mirror. Depending on reflection of light. Depending on reflection of light, I'm taking the concave mirror like this. Mirror whose reflection takes place inward. So this is the pole. Okay. So here after incidenting like this. Object, actually this is the concave mirror. Concave mirror is also known as converging mirror. Convex mirror. Convex mirror is also known as diverging mirror. Okay. So concave mirror is converging, convex mirror is diverging because whenever light ray falls on it, the light rays will converge and meet on the principal axis. After reflection, the light rays will meet on the principal axis. That's why it is called converging. Converging. So after reflection, the light rays will move towards the principal axis. After reflection, the light rays will move towards the principal axis. That's why it is called converging mirror. So convex mirror. Convex mirror. Convex mirror is also known as diverging mirror. Convex mirror. Convex mirror. Convex mirror is also known as diverging mirror. Diverging mirror. Because When the light ray incident on it, the light rays are, if the light ray incident on it, after reflection, the light rays are moving away from the principal axis. After incidenting, light rays are moving away from the principal axis. That's why it is called diverging mirror. Converging mirror means after incidenting, light rays are moving towards the principal axis. That's why converging. Diverging means after reflection, the light rays are moving away from the principal axis. That's why it is called diverging mirror. Is it clear? Next one, ray rules of concave mirror and convex mirror will do it. So we'll learn concave mirror, convex mirror ray rules. Those are spherical mirrors. The mirror which is in the form of curved shape, that is called spherical. So depending on the reflection, concave mirror. So concave mirror, next one, convex mirror. Convex mirror. Convex mirror. So before this, so we'll discuss about terms related to spherical mirror. Okay, then we will go to this one, then it is easy. So let it be concave mirror and convex mirror only. Okay, let it be concave, convex. So terms related to spherical mirror. Terms related to spherical mirror. So it is a part of the sphere. So this is a part of the sphere. This is a part of the sphere, right? So I'm taking this is the part of the sphere. So here I'm taking this one. Center of the imaginary sphere in which mirror is a part. Center of the imaginary sphere in which mirror is a part is called center of curvature. So I'm taking the concave mirror like this. Center of the imaginary sphere in which mirror is a part. The midpoint of the mirror is called pole. Midpoint of the mirror is called pole. Line joining of center curvature and pole is called line joining of center curvature and pole is called principal axis. First one is center curvature, second one is pole, third one is principal axis. Principal axis. Principal axis. Okay, and coming to the fourth one, radius of curvature, the distance between center curvature to pole. The distance between center curvature to pole is called radius of curvature. The distance between center curvature to pole is called radius of curvature. The distance between center curvature to pole is called radius of curvature. After reflection, all light rays are meeting at one point on the principal axis. After reflection, all light rays are meeting at one point on the principal axis. That is called focus. Focus. This is called focus. So fifth one is focus. Okay. Focus. So focus. The distance between focus to pole is called. The distance between focus to pole is called. Focus to pole is called focal length. The distance between focus to pole is called focal length. And the seventh one, the width of the mirror is called aperture. Width of the mirror is called aperture. Aperture. Width of the mirror is called aperture, right? So these are the points. One check. One check. Okay, so we'll discuss remaining points. So terms related to spherical mirror. Terms related to spherical mirror. Central curvature, pole. So So next one we'll go to the ray rules of concave mirror and convex mirror. Okay, 12th class, 12th and 11th. So I'll take time. After that I will start because now 10th class is going on. So due to schedule problem, that's the reason I didn't start. I will start. Soon I will start. Alpha Gaming and Master, both of you. I'll start. So ray rules. So ray rules, I am going to explain about ray rules of concave mirror and convex mirror. Now we will discuss because if those points are there, only physics, only physics. I'll teach only physics, no other subject. Uh, okay. So ray rules, concave mirror, convex mirror. First point. So plane mirror I'm taking. Sorry, concave mirror, pole, focus, center of curvature. Light rays coming from infinity after reflection passes through focus. Second one. So pole, focus, center of curvature. Light ray will passes through focus. Light ray will passes through focus. After reflection, it moves towards principal axis. Third one, if the light ray passing through center of curvature, so pole, focus, center of curvature, if the light ray passing through center of curvature, it retraces its original path. So, and coming to fourth one, if the light ray incident at the pole, pole, focus, center of curvature, light ray incident at the pole, it reflect back. Next one, coming to convex mirror. First one, convex mirror. So pole, focus, center of curvature, light ray is parallel to the principal axis after reflection passes. So reflect away, move away from the principal axis. Second one, light ray is passing parallel through the focus. Pole, focus, center of curvature, light ray passing through the focus. After reflection moves towards infinity. Third one, light ray is passing through the center of curvature. Pole, focus, center of curvature, light ray passing through the center of curvature, it reflect back in the same path or retract its original path. So it is passing through the center of curvature. Coming to the fourth one, convex mirror. So pole, focus, center of curvature, light ray incident at the pole. It reflect back. Pole. So it reflect back. So write a reflection. You can observe now. Okay, so these are the ray rules of concave mirror and convex mirror. Light rays coming parallel to principal axis after reflection passes through focus. Light rays passing through the focus after reflection moves towards infinity. Light ray passing through the center of curvature, it retraces its original path after reflection. So it incident the pole reflected back. So convex mirror, light rays coming parallel to the principal axis after reflection moves towards away from the principal axis. Light ray coming through the focus, passing through the focus after reflection moves towards infinity. Light ray is passing through center of curvature, it retraces its original path, and a light ray is incidenting at the pole, it reflects back. So these are the ray rules of concave mirror and convex mirror. Okay, so next one we'll discuss about image formations of concave mirror. So image formations of concave mirror. Next, the convex mirror we'll discuss. Okay, so we'll see. Ray image formations by concave mirror. Concave mirror image formations. Image formations by concave mirror. So first one, I'm taking the concave mirror. So pole, focus, center of curvature. Object is at infinity. Light rays are coming from infinity. Light rays are coming from infinity. How many light rays are required to form the image of the object? Minimum 2 light rays. Minimum 2 light rays are required to form the image of the object. Minimum 2 light rays are required to form the image of the object. Image is formed at focus. Nature of the image is real and inverted, highly diminished. Coming to the second one. So pole, focus, center of curvature. Object is placed beyond center of curvature. Object is placed beyond center of curvature. One light I am taking like this. So it passes through focus. Another light ray I am taking, passes through center of curvature. So after reflection, the light rays will meet between C and F. So image will be formed here. Object is beyond center of curvature. Beyond C, image is forming between C and F. Nature of the image is real and inverted. Size of the image is diminished. Compared to object, image size is reduced. So diminished. So next one. Third one. Third one. Object pole, focus, center of curvature. Object is placed at C. Image also will form at C. Object is placed at C. Image also will form at C. So one light I am taking like that at pole. So it will be reflected back. Incident at C. So object at C, image also at C. Nature of the image is real and inverted. Size of the image is same size. Same size. Coming to fourth one. Fourth one. Object is placed between C and F. So pole, focus, center of curvature. Object is placed between C and F. Object is placed between C and F. Image will form beyond center of curvature. Object is placed between C and F. Image will form beyond center curvature. Image will form beyond center curvature. Beyond C. Nature of the image is real inverted. Real inverted. And size of the image is enlarged. Nature is real and inverted. And size of the image is enlarged. Coming to the fifth one. Object is placed at F. Light I'm taking like this, passes through focus. Object at F, image will form at infinity. Nature of the image is real and inverted. Size of the image is highly enlarged. So last diagram is very important. Hi everyone, welcome to the class. Hi everybody, welcome to the class. Okay, so this last diagram is very important. Last diagram is very important. 3 marks question will come for exam. So make sure that you are practicing sixth case. So we can call this one as a sixth case. So I'm taking like this. This is the pole, focus, center of curvature. Pole, focus, center of curvature. Pole, focus and center of curvature. Object is placed. Object is placed between F and P. How many light rays are required to form the image of the object? Minimum 2 light rays are required to form the image of the object. I am taking 2 light rays. So the image will form here. Object is placed between F and P. Image will form behind the mirror. Behind the mirror. Nature of the images. Behind the mirror, nature of the images. Nature of the image is virtual, erect and enlarged. Virtual, erect and enlarged. Nature of the image is virtual, erect and enlarged. Nature of the image is so I'm considering here object is placed between F and P. Object is placed between F and P. Image will form behind the mirror. 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 Nature of the images. Nature of the images. Nature of the images. Nature of the image is virtual, erect and enlarged. Virtual, erect and enlarged. Virtual, erect and enlarged. Nature of the image is virtual, erect and enlarged. Virtual, erect and enlarged. So this is about concave mirror image formation. Concave mirror image formation. Now we'll discuss about convex mirror image formation. Convex mirror image formation. We'll see convex mirror image formation. Convex mirror image formation. Convex mirror image formation. Convex mirror. Convex mirror. Convex mirror image formation. Object is placed. Image is forming. Object is placed. So this is about concave mirror image formation. Next one we are going to discuss about convex mirror image formations. Convex mirror image formation. Convex mirror image formation. Only two cases are there for convex mirror. Object is placed at infinity. One case, and second case is object is placed between infinity and pole. Only those two cases. So object is placed between. So I'm considering now. So object is placed at infinity, image will form at infinity. Nature of the image is virtual, erect and highly diminished. Virtual, erect and highly diminished. So that is about 1 point. Coming to one more point, object is placed. Virtual image, the mirror which forms always virtual, erect and diminished image. That is convex mirror. The mirror which forms always virtual, erect and diminished image. Virtual, erect and diminished image. That is convex mirror. Only two cases are there. So now we'll see. Convex mirror image formations. Okay. Convex mirror image formations. So first image formation is convex mirror. I am taking convex mirror like this. So here I am considering this the pole, focus, center of curvature, pole, focus and center of curvature. So pole, focus and center of curvature. Object is placed at infinity. One lighter I am taking like this. One lighter I am considering. One lighter I am considering like this. How many lighters are required to form the image of the object? So one lighter one lighter Kumar. So I can take it as a suggestion. Definitely, I look into that. Thank you for suggesting. So Agam Kumar, thank you. So here I'm taking like this. So this is one light ray, this is one more light ray. Okay. So I'm considering object is at infinity. Image will form at focus. Nature of the image is virtual, erect. Nature of the image is virtual, erect and highly diminished. Highly diminished. So hi everyone, welcome to the class. So here object is at infinity. Object is at infinity. Image will form at focus. Nature of the image virtual, erect, and so size of the image is highly diminished. Size of the image is highly diminished. Size of the image is highly diminished. Okay. So next one we are going to discuss about second image formation. Second image formation. Object is placed. Object is placed. So this the focus, focus and center of curvature. Object is placed between P and object is placed between pole and infinity. So one light ray I am considering here. This is one light ray. So it will be reflected back. So another light ray I am taking at the pole. Those that also reflected back. So if you are extending those light between P and F, object is placed between P and infinity. So image will form between P and F. Image will form between P and F. Nature of the image is virtual, erect, and size of the image is diminished. 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 Okay, so this is about size of the image is diminished. Next one, next one, that is new Cartesian sign convention. New Cartesian sign convention. All distance are measured from the pole. Distance are positive along the instant trace. Distance are negative opposite to instant trace. Distance are positive above the principal axis. Distance are negative below the principal axis. New Cartesian sign convention. New Cartesian sign convention. All distance measured from the pole. Distance are positive along the instant trace. Distance are negative opposite to instant trace. Distance are positive above the principal axis. So here I am considering the concave mirror. Concave mirror is here. I am considering like this. So here pole focus, center of curvature, pole focus and center of curvature, pole focus, center of curvature. So in the direction, all measurements we have to take from the pole. All measurements are taken from the pole. All measurements are taken from the pole. In the direction of incident rays, 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 image distance, focal length, radius of curvature all are positive. Opposite to incident rays. So object distance, image distance, focal length and radius of curvature. Even if you are taking along the incident rays, along the incident rays, along the incident rays, along the incident rays, object distance, along the incident rays, along the incident rays, object distance, image distance, focal length. So object distance, along the incident rays, object distance, image distance, focal length and radius of curvature are positive. Opposite to incident rays, object distance, image distance, focal length and radius of curvature negative. Above the principal axis, height of the image and height of the object positive. Below the principal axis, height of the image and height of the object negative. So according to the coordinate axis, if you are taking this the origin, positive x-axis, negative x-axis, positive y-axis, negative y-axis. So according to the coordinate axis, we can consider so sign conventions as it is and compare with the sign conventions. Okay. So positive x-axis along the incident rays all are positive. Opposite to incident rays all are negative. Above the principal axis all are positive. Below the principal axis all are negative. Yes or no? So this is about sign convention. Sign conventions. New Cartesian. So this is also called new Cartesian sign conventions. New Cartesian sign conventions. Simply we can say sign conventions. Sign conventions. So new Cartesian sign conventions are simply we can say sign conventions. New Cartesian sign convention. New Cartesian sign convention. All distance are measured from the pole. Distance are positive along the instant rays. Distance are negative opposite to instant rays. Distance are positive above the principal axis. Distance are negative below the principal axis. New Cartesian sign convention. New Cartesian sign convention. So this is about new Cartesian sign conventions. Next one, mirror formula. Mirror formula 1 by f equal to 1 by f equal to 1 by u plus 1 by v. So magnification equal to my height of the image by height of the object. That is nothing but minus v by u. So magnification of the mirror. Magnification of the mirror, height of the object by height of the image by height of the object, height of the image by height of the object minus v by u. So mirror formula 1 by f equal to 1 by u plus 1 by v. So this is about new Cartesian sign conventions. I hope it is very clear. So thank you so much for joining and attending and interacting. So we'll see you in the next class. So see you soon. So if you like this content, do like, share and subscribe to Student the Brand. If you like this video, please do like, share and subscribe to Student the Brand. You can inform your friends, asking them to join to the class. Thank you so much. See you soon. This is your sir from Student the Brand.